Welcome to Pure Mathematics 1, Chapter 6, Integration. Topic, Reversing Differentiation. So first of all, we have two processes which is called integration and differentiation. Let's say I have the equation y equal to x cubed. So from here, I get my dy over dx will be equal to 3x squared. So this process from here to here is called the differentiation. And now the integration is the reverse process of the differentiation. So from here to here we call the integration. For example, for differentiation, you have the equation of the curve, and now you want to find the gradient of the curve, so you use differentiation. But now we have the gradient of the curve, and then we want to go back and find the equation of the curve. So we would use integration. So now I would provide you the general formula for integration. Let's say you have y equal to x to the power of n plus 1, right? So when you differentiate it, dy over dx equal to n plus 1 multiplied by x to the power n, right? So now we will have y equal to x to the power of n plus 1 over n plus 1. So we will differentiate it, y over dx equal to, because n plus 1 is a number, here is a number, it's not, n is here is not a term, it is a number. Let's say n is 3 or something like that. So please don't confuse between them. So we will have, because n plus 1 is a constant, so we will have n plus 1 multiplied by x to the power n over n plus 1, bracket here, equal to x to the power n. So from here we have, from the dy over dx equal to x to the power of n, so we want to find the equation y. So the equation y will be equal to x to the power of n plus 1 over n plus 1. Let's say from this equation here, have dy over dx equal to 3x squared, okay? So my y will be equal to, I will use this formula here. In this case, we have a constant here. Let's say we have a constant here, and here I will keep 3 here, and then because it is x to the power 2, so n equal to 2, so you have x to the power 3 here, because n plus 1 equal to 3 over 3 equal to x to the power 3, which is exactly this one. Okay, let me take another example. Let's say dy over dx equal to 4x cubed minus 2x squared plus 3x. So our y will be equal to 4 multiplied by x to the power 4 over 4 minus 2x to the power 3 over 3. The power of this one is exactly the denominators in here, plus with 3x squared over 2. So the formula for y will be equal to x to the power 4 minus 2 over 3 x cubed plus 3 over 2 x squared. So it is how we can find the equation from the gradient by using integration. And remember that integration is a reverse process of differentiation. When we differentiate an equation like this, y equal to 3x squared plus 4x minus 5. So we then differentiate it into 6x plus 4. We only differentiate the terms which contain x and we ignore the constant term. So when we convert it back, we don't know which one is the right one. Maybe this equation 3x squared plus 4x plus 9 will give the same result as this one, 6x plus 4. So that's the same. So we cannot identify the exact equation that we use at first. So now we will find a way to solve that problem. Let's say you have the dy over dx equal to 3x squared minus 6x plus 4. And now we want to find the equation of the curve, which is y equal to 3, we keep it the same, x to the power 3 over 3 minus 6x squared over 2 plus 4x. And now we don't know what is the constant term, so we would plug c. C is a denotation for a constant, because we don't know the exact number of c. So now we'll find a way to find c. And we know that for a particular graph, it will pass through some particular point, and they are not the same. Like I have the graph for x squared, which is this one, x squared here, x squared, y equal to x squared, y equal to x squared minus 2. We down here, then depending on the constant term, they will travel along the y-axis and they do not meet each other. So they have particular point on them. Like this point here, we have same value of x but different values of y. So for this one, if we have the coordinate of a point on this graph, we will know how to find the constant c. From that, we can find exact equation of the curve. Let's say this one passes through the point 2 and minus 5. The curve of this one will pass through this point. So now I will substitute it into here to find the constant c. And let me rewrite this one and simplify it. X cubed minus 3x squared plus 4x plus c. And now I will substitute these two in here. We know that y equal to minus 5 equal to x equal to 2, so 2 to the power 3 minus 3 multiplied by 2 to the power 2 plus 4 multiplied by 2 plus c. So we will have minus 5 equal to, all the thing here is 4 plus c. So c equal to minus 9. So the equation we want to find is y equal to x cubed minus 3x squared plus 4x minus 9. Here, this one. So it's how we can solve a question related to integration.